Square root of x plus 9 minus square root of x equals 1. Solve for x. Most people get this wrong, not because they cannot do the algebra, but because of what happens after they solve it. Here is the move. Isolate one radical, square both the sides and solve like you normally do. Let us watch how to do it in this case. Isolate first, move the lone square root of x to the other side. So root of x plus 9 equals 1 plus root of x. Now square both the sides. X plus 9 equals 1 plus 2 root x plus x. The x's cancel on both the sides, leaving 8 equals 2 root x. Divide by 2, root x equals 4. Now we square it, x equals 16. So x equals 16. Done, right? That is where most people stop, and most people are wrong to stop here. Anytime you square both sides of an equation, you risk creating a solution that does not actually work in the original equation. So before you circle x plus x equals 16 as your final answer, you will have to plug it back in and verify. Root of 16 plus 9 minus root of 16. That is our expression. Now we do the root of 16 plus 9, that is root of 25 minus 4, which is again 5 minus 4. This equals 1. So it checks out. X equals 16 is genuinely valid here. But on a harder version of this problem, it might not be. This is the single most common way students lose points on radical equations. Not the algebra itself, but skipping the verification step. Anytime a problem has a square root in it and you square both the sides, checking your answer is mandatory. It is part of the solution. Let us look at a quick example. Square root of x plus 2 equals minus of x. It looks almost identical to the earlier problem. Now we square both the sides and we get x plus 2 is equal to x square, which is equivalent to x square minus x minus 2 equals to 0, which on factorization gives us two solutions. One is x equals to 2 and one is x equals minus of 1. Now we check them. Plug in x equals to 2. So our expression is square root of x plus 2, that is square root of 2 plus 2, which is square root of 4, that equals 2. But minus of x is equal to minus 2. So that doesn't match. That is an extraneous root. So hence the solution is rejected. Plug in x equals to minus 1. Square root of minus 1 plus 2 is square root of 1, which is 1. And negative of x is also minus of minus 1, that is 1. So that one checks out. Radical equations are one of the highest value topics to master for any examination. I am covering more of these every week, so subscribe if you want the next one. Comment checked under the video if you caught the extraneous root trap before I revealed it. See you in the next one.